Hi guys, welcome back to the last segment of the show. So we've looked at a lot of things, guys. We started with investigating. We then looked at if that is the investigation, what do we observe? We called it a what? A conjuncture, right? And then from there with the conjuncture, we said, okay, we don't just leave it there because really we are smart people ourselves. So we then go further and say, okay, let's try and prove this thing and see exactly why is the conjuncture always true or not always true. And remember that question I asked you, are our conjunctures always true? No, they are not always true, provided you prove them. If you prove them and you change everything and the proof still holds, then they will always be true, given that you prove them. Now we're going to look at what you call the converse of this and also a corollary of this. But I know I'm throwing a lot of big words, guys. But guys, you really need to know these terms. If you don't know them, just write them down as you're seeing them. Go to your dictionary, your maths dictionary, and look at what they mean so that you can familiarize yourself with them. Because going forward with your maths career in school, I promise you, you're going to be seeing a lot of them and you need to understand what they mean, right? So far, we've looked at the radius, a chord, twice the radius we said is our diameter. And then we looked at our theorem, which is a line drawn from the center of a chord, of a circle, perpendicular to the chord. The condition is it must be perpendicular to that chord, then the chord is bisected. Our reason, we said we normally shorten these things, guys. Remember I said the perpendicular is like an upside down T, right? So it's line from center perpendicular to chord. And then from here, the converse of this is to say, if a line now is drawn from the center of a circle to the midpoint of the chord, then the line is perpendicular to that particular chord, right? And then the reason for that will always be line from center to midpoint of chord. And midpoint, we normally shorten it that way. Guys, we are very smart people. We don't really need to show people that we know the English words of these things because our mind is always about communicating mathematically. So we normally shorten those things. Now we have what we call a corollary, and with a corollary is to say if all of that is true, then this would then be the case, right? So it means the perpendicular bisector of a chord always passes through the center of the circle, right? And this is perpendicular bisector of chord, which perpendicular like that or perpendicular like that as an upside down T. Now let's just try and prove this and put this into context, right? And see exactly what is it that we need to do. Now, what do we know? We know that in a circle with center O, I said I need to tell you something. The O is the center of the circle. If I did not say this, you don't assume that the O is the center of the circle, please. Excuse me. And then RT is equals to 8 centimeters, right? So this whole length there is 8 centimeters, excuse me. And then OS is 3 centimeters, as you can see, I've shown you. RS is equals to ST, right? RS is equals to ST. So this is equals to that. Very fast cars. RS is an Audi, you know, and ST will be Ford. And they are competing because they are all fast. But anyways, we are not there. So if those two are equal, it makes this one 8 and 4, I mean. It makes this 4 here and it makes this 4 because they are both supposed to add up to 8 centimeters. OB is perpendicular to AC. We know that. They just showed us there. If that is the case, remember, then we can claim that those two are equal. And since they told us that these two are equal, then we can claim that we have a 90 degree there. So far, you can see, I don't know anything about the questions. I am only analyzing the statement. OB is equals to 4 centimeters. You can see it there. Now, as I just said, I don't know anything about the questions as yet. I'm just analyzing the statement. Please stop this thing of always when you open your calculator or anything like when you open your question paper, the very first thing you want to do is to on the calculator as though you're going to take pictures of the question with the calculator and it's going to solve it for you. No. Read to understand, and then apply what you understand to the diagrams, and then go to the questions. Don't read, look at the diagram, and you are rushing as the flash to the questions, and you don't understand what is happening on the statement and the diagram. You don't do that. So if your diagram looks clean after you answer your questions, then I promise you, you did not do the right thing. You must first make your diagram dirty by trying to apply everything that was said on the statement so that it makes sense. And you will see after doing that, you would have answered a few of the questions already. So please note that. Now, let's try and see what do they want us to actually do. So remember that this is 4, that is 4, therefore this is 90 degrees. So calculate the length of OA, right? The radius of the circle. So OA is the same as OR, is the same as OT, it's the same as OC. So it means I can calculate any of them, and then at the end I will just claim that OA is equal to whatsoever that I calculated, provided it has sufficient information there. The first thing that I will need to do first will be to say RS is equals to ST, right? Why? This I was given, I was told. Oh, by the way, I will just say this is equals to 4 because they did tell me it's equals to 8 as a total, right? Therefore, I will then say that OS is perpendicular to what? RT. Remember my reason. I said line from center to midpoint, right, is perpendicular to that. So already I know that. Why am I doing this? Is because I am now trying to find OR, because that's where I have sufficient information. So therefore, after claiming all of this, I will then say that in triangle ORS, then I can try and talk about it. I know that I'm going to have OR squared is equals to 3 squared plus 4 squared. Why do I then use Theorem of Pythagoras? Why? Because I have a 90-degree angle. Remember, that's what qualifies me to use the Theorem of Pythagoras. And then from there, I said it was OR squared is equals to 3 squared plus 4 squared. 3 squared, you know, will be 9 plus 4 squared is 16. This is equals to 25, right? And that's OR squared. Then my OR will be equals to 5 centimeters, right? Therefore, OR is equals to OA is equals to 5 centimeters. Reason, radii. Please, you don't make claims and not give me reasons for them. Then I will just quickly make it incorrect, because we don't make baseless accusations in math. Then calculate the length of AC. So now I know that this length here is 5, right? Now they want me to find the length of AC. With AC, I can find AB, because that's where I have sufficient information, times it by 2, it gives me AC. Firstly, why will I need to do that? Firstly, I claim, right? I say that OB is perpendicular to AC. And what is this? We were given this information. Since this is the case, we can then say that AB is equals to BC. Why? It is line from center perpendicular to chord, right? That will be my reason. Remember when we were looking at the theorem, I said that's the reason. And then from there, I can then talk about in triangle. I said this is a language, guys. You don't just write things and then I need to wonder where this comes from or something like that. You treat me as a person who does not know anything. You communicate with me and tell me, look here, look here, look here, so that I can see all that you are saying. I will then say that AB squared is equals to 5 squared minus 4 squared. Remember, it's the theorem of Pythagoras, and this will be 5 squared, we know that is 25, minus 4 squared will be 16, and then if that is the case, 25 minus 16 we know is 9. All right, let me just go to the other side. So we are now on AB squared is equals to 9. It means that AB is equals to 3. Therefore, AC will then be equals to 6 centimeters. And that's where I leave it. And then, you know, easy peasy, lemon squeezy. Now, let's just look at a summary of all that we've done so far. 1, we said we have a chord and radius theorem. Line from center perpendicular to chord. If a line is drawn from the center perpendicular to the chord, it bisects the chord, right? Bisects the chord. Also, the second one, which we said was the converse, if a line is drawn from the center to the midpoint of the chord, the conclusion, okay, so let me do this. Conclusion. The conclusion is that it is perpendicular to that chord. Lastly, a perpendicular bisector of a chord, what does it do? It passes through the center of the circle. So far, guys, we've looked at the concept of the radius, the concept of a chord. At a later stage, you will see we'll look at other things in terms of the concept of circle geometry, and that's what is important. So, remember the big thing here. You do not make a claim unless, 1, the statement gave you a clue that this is the case. So I tell you center O. That means I have a center. I don't mention a center, you don't talk about a center yourself. Number 2, you don't make a claim if you cannot prove it, right? You make a claim based on the theorem because the theorem was proved. By the way, you saw that the theorem that I was using, I was not proving it. Why? Because it's already a theorem. I was just trying to show you where it comes from. So not that every time I use the theorem, I need to start by proving it and then use it. No. Already it's been proven and it's been claimed to be a theorem. I just use it because why? The given information does qualify it to be a theorem, and for me to claim that this is equals to that, that is this, that is 90 degrees and all of that. So make sure that you understand those. Also, please know the difference between a theorem and its converse. If this is true, that can also be true, right? Based on this and that. I know I'm saying a lot of this and that, but I hope you understand everything that I've said so far. Guys, from me to you, remember, mathematics is food for the soul. I will see you next time.